Hello and welcome to Shapes 2. This is going to be a complete overview of my Make Anything machine that I've created. It's in hard mode, so there's only 4 layers instead of 5, where there would be an insane mode. So let's get into the logic first. So we're starting with a global wire receiver. I have it set to channel 0 because I used multiple of them in the build. So it's like if I want to change the shape to not be like a random shape, instead of having to change all of them, I can just disconnect it here and then input whatever shape I want. So, of course, the logic starts with unstacking the shape. And the way I have my machine set up is that it will always have the bottom layer as the first section, right? This is the bottom layer, this is the second bottom, third bottom, and this will be the top, if there are 4 layers. And that requires a bit of logic. The other way to do it is to have the top layer always be the first section, which makes the initial logic easier because it's always going to be the first unstacker is always going to output the top layer. But then later on, when you're stacking the final shape, it requires more logic than doing it this way, where I'm stacking from bottom to top. So the way this works is pretty much this. So right here, this is the output of the top layer, right? If the top layer, if there's a second layer, then this unstacker will be powered, right? And this NOT gate nullifies the output of the top layer, right? So if there was no second layer, the top layer would just be outputted because this NOT gate would be off, and it would just output the top layer. But since there is a second layer, this NOT gate's outputs off, and then the top layer is not outputted. And if there's a third layer, it's the same thing. So this would be on, which makes this, and this unstacker would be here, powering this, which would be the third layer, and it would turn this NOT gate off, or I guess on, and it would prevent the second layer from being outputted as the layer. And then if there's a fourth layer, it prevents the third layer. And since there's no fifth layer, if there's a fourth layer, it's just outputted, right? Because there's not going to be anything after that. And then this part basically removes the bottom layer of the shape, right? So instead of an unstacker that removes the top layer, this removes the bottom layer. How that works is that basically it takes the output from the top layer. If the top layer is on, the top layer would be this layer, right? Then it powers the third layer from being on. And if the third layer is on, it powers the second layer, and if the second layer is on, it powers the first layer to be on. But that's like if you after you remove the bottom layer. And then it's basically the same mechanism repeated, except this is you only need 3 layers for this one, and then the next one's 2 layers, and the next one's 1 layer. So the next section is basically deconstructing the layer for each shape. So we're starting with our 4 analyzers, which are gonna analyze each corner of the shape. So we're just rotating by different amounts. And then this is basically a checker, right? It's gonna check for 2 things. Is the shape is the layer, or is the corner a crystal? And is it a pin? And we have to check for if it's a crystal, because if it's crystal, that means we have to put it through the crystal machine, right? And I didn't really want to check for if it's a pin, but I kind of had to, because the way I have this set up is that after it analyzes with the color and the shape, it directly repaints the shape, right? And repainting works for uncolored shapes, mind you, but it does not work for pins, unfortunately. So I can demonstrate that here. If I just have a pin shape, right? That's just 4 pins. And then if I analyze and then try to repaint it, it has no output, right? Because the pin has no color, right? An uncolored shape, if I do an uncolored shape, that still has a color, but since pins don't have colors, you cannot repaint them. which means I have to do a special check for a pin. And this basically says if it's a pin, then just bypass this painting stage and then just output it to the wire, right? So that's not too complicated. The crystal check is requires a bit more, because after we check for if it's a crystal, I then have to output this. I have to signal that it needs to go in the crystal machine, which is basically this top wire. So these bottom wires are each of the corner, right? This is just each corner shape, right? These are just corner shapes right here. And right now I have it set to this shape, so it's just two squares. And these top two wires, this wire signals that it needs to go through the crystal machine, right? And I just have this set to the color. So like if it's basically how it works is that if it detects a crystal, it outputs whatever color it found, right? So this is the color. So this wire, it outputs the colors through the gate if it equals a crystal, right? Okay, that's pretty simple. That's not too complicated. So this line's gonna be a color. The thing is that it's possible to have a shape or have a layer be only crystal. Because if you have a shape and then pin push it and then put it through the crystallizer, that the layer with pins will become a full crystal layer, right? So if I'm doing one layer at a time, the only way to make a full layer, or I think the easiest way to make a full layer of crystal is that you put pins. You can so in this game, there's a way to get pins alone, right? Pins don't always have to be under shapes. You can get just pins alone. And if you have a pin on the top layer, and then put it through a crystal machine, that top layer will become crystal, right? If you didn't have a pin there, the top layer would be ignored, because you need to have at least like something on the layer for it to be crystalled, right? So basically, if there's a crystal, well, if there's only crystal on the layer, then this line activates. So this line signifies that there is crystal. This line signifies that it's only crystal, right? And basically the logic is that I just have 3 OR gates here. So or 3 AND gates rather. So it's basically checking if this is crystal and these 2 are crystal. If all 4 are crystal, then this outputs as the crystal line. And also have it so if it's crystal, then all the corners shut off. I found that to be the easier way, because the other way you would do it is that if it's crystal, the other way would be like you can output crystal to the corners as well. I guess it doesn't really matter for my machine, but I just did it that way for convenience, I guess. So yeah, I think that's the entire spaghetti mess here. It's just checking for pins and crystals, and if it's a crystal, it outputs the color of the crystal. And if it's only crystal, then it outputs this line. And this is also color of the crystal. So yeah, and that's just repeated for all 4 layers. But then now we just have wires. So yeah, I made some wire tiles. The alternative to making wire tiles is to use the global wire transmitter, but I kind of didn't want to because I kind of want to intend to make multiple anything machines, which would mean using different channels, right? And if I use different channels, I don't want to overuse the channels here. So I instead just made wires. And I'm gonna accept this shape. Gotta make the next one. There's a lot of random shapes. Alright. Alright, there we go. So the next step is shape selection. So after we've deconstructed the shape, basically this is just all possible shapes right here, right? So we have rectangle, circle, star, and W, or whatever you call it. And then the 5th shape is a pin. Yeah, I don't know. I have a lot. The train lines are like really, they seem to be a little inconsistent. it's a very long. Look at this. This is the whole line. It's very long. I made it that long because I wanted one train to have all 5 shapes on it, so it has to go through 5 stops. Yeah. So basically, we have 5 shapes, and they're being. This is just a filter, right? It just. So yeah, I've labeled it. So this is the northeast corner right here. These are all possible northeast shapes, and it pretty much checks, right? Is northeast? Well, it just uses belt filters, and it outputs. It analyzes the shape, and then it outputs the shape without the color. So if it's the correct shape, it'll just output it, and if it's not, it trashes it, right? And I just have that 5 times for all the shapes. I also have another circuit that it basically detects if there's no shape, this circuit. So if there's no shape, then it also, I want to trash it as well, because if it doesn't trash, then it causes backups in the system. And the reason I need this is because if you have a belt filter and there's 0 signal, so about like this, it doesn't go into the X, it just does nothing, right? But I want it to go to the X. So pretty much what I did is it detects if there's no signal, then it turns the signal into a 0, right? Because if it's a 0, so like if I turn this off, if it's a 0, as you can see, it goes to the X. But if it's nothing, it just stops working. So hold on. The way this works is pretty much it checks. Well, if it first checks if the shape's on, right? If it's on, then do nothing, right? It doesn't need to output a 0, because if you output a 0 and null are very different, right? Because 0, if you output a 0 and it's outputting a shape, it will become conflicted. I can show that, right? If I output a 0 here, it creates a conflict, and I don't want that. So I want it to only output if there's no shape, and so that pretty much does this. And this is a null. This just detects if there's if the wire is empty. So if there's nothing on the wire, then it just outputs a 0. So it's not too complicated. But yeah, and then the signal is just passed on, so I can repeat the I can tile the entire thing. Yeah, and I just have train lines for each color. Yeah, 4 different colors for 4 different corners, right? So then these are the same. Yeah, so that's pretty simple. So after that, we move on to the painter. So we need to paint each corner separately because they can all be different colors. So the way the painter works is that I've created, well, first of all, I create a bypass system, because if the shape's uncolored, you don't want to be going through the painter because it'll just get stuck. So this just detects if the shape is uncolored, right? If it equals uncolored, this is the uncolored, then it just bypasses the entire thing. If it's not uncolored, then we have a color decoder, which it's simpler than it looks. It basically has, so there's 7 bypass valves, and this just helps. This makes the machine because instead of producing all 7 colors at once, which requires a lot of color, I just have RGB here, and then it automatically determines which color it needs to make. So let's say, so right now it's uncolored, yeah, but let's say I can change the color to let's do magenta. So if it's magenta, the way it works is that I've labeled them. So we have 7 lines. So the lines that are on are the red bypass, the red line, and the blue line. So of course we want blue and red to be on, because we need blue and red to make magenta. So blue and red just correspond to is the color even being like released into the system? So we have blue and red being released. And then the red bypass, it bypasses the initial mixer, right? Because we can only have two colors going into one mixer. So if we don't want red and green mix, right? The red needs to bypass this mixer, which is basically this second pipe gate system. It says, we're not making yellow, so we need to bypass this mixer, and then it can make magenta like that. Let's reconnect this. And this is basically a bunch of checks, right? So, for example, for blue, this just checks for all colors that contain blue, right? So white contains blue, cyan, magenta, and blue. So if it's any of those, it's going to release blue into the system, right? And the blue bypass checks. Well, the blue bypass only needs to check for blue. If the color is blue, then it needs to bypass this mixer, right? But if it's any other color that's not blue, but it contains blue, right? If it contains blue but it's not blue, then you don't want to bypass the mixer. And it works the same way for the green and the red. And then we also have the seventh pipe gate is the mixer bypass. So if we have let's say we're making yellow, we need to, but we don't want to mix it an additional time with the second mixer because with the first mixer we've already made the correct color. So we're just going to bypass the second mixer. Yeah. So that's basically this entire color mixer. It's just a bunch of pipe gates and then a bunch of checks, right? Checking if it's the correct color, or it's basically decoding the color into what gates need to be opened. And then that's connected to the painter system, which is a pretty simple painter system I made, I guess. I don't know. I guess it's reasonably compact. It's definitely not the most compact you can make it, but it works well. I guess the important thing to note is that you can have how many is this? You can have 16 mixers for one pipe. That's the most important thing. At max level, at least. At lower levels, you can have, I guess you can have more, but yeah, at max levels, one pipe can connect to 16 mixers. So yeah, that's the entire painting system. And then of course we have our 3 paint inputs on the train. Yeah. So that's not too complicated, I guess. So after mixing, we're on to stacking. And for stacking, you have to do a bit of logic because you need to know if you want to bypass the stacker or if not, right? So let's say we have our first corner, and this isn't flow. And sometimes the belts, if they have things on them but they're paused, it makes it look like they're flowing, but they're not. Anyways, yeah. So right now it's bypassing this stacker because I believe it's this. Yeah, this and this are the two places being outputted. So that means we need to bypass, because it's only a half shape, right? So that means we need to bypass these two stackers. The way it does that is it just checks if the next corner is outputted or not, right? So if this is like the northeast corner, right, and this is the northwest corner, this just checks. This is the northwest line. So it just checks, is the northwest line on, right? If it is, then go to the stacker, and if it's not, then bypass the stacker. Oh, it's actually one more important detail. I forgot to mention. For these 5 shapes, if it's yeah, so these 4 work normally, but this the pin shape, it's special because I want pins to be released if the shape contains a pin, or if the shape is only crystal, right? Because that's how we're creating the only crystal. So I guess there's an additional check here, where it's so you do the normal checks, but then there's an additional line that checks, this is the only crystal line. If this is on, then it just outputs the pin. That's pretty simple. Yeah. So yeah, the way the stacker works is that I just have like a belt filter here, where if there's a corner, or yeah, there's actually two conditions. If it's a corner, or if it's only crystal, right? Because if it's only crystal, I want all 4 pins to be active, right? So if it's only crystal, I want to be stacking as well. So those are the two conditions. If it's only crystal, or if the next corner that's connected to the stacker is active, right? If it is, then I just have a NOT gate that turns this off, and it is sent to the stacker. And if it's not active, then it just bypasses it. And I have like kind of the same thing here, where is the previous corner, is that active, right? And currently there's nothing being outputted, but yeah, if the previous corner is outputted, then go to the stacker. If it's not being outputted, then bypass it, right? And I just have this repeated for each corner. But for the this bypasser, this needs to, remember, if you're gonna build this, you have to check for the previous 2 corners, right? Instead of just, so this one's just this corner being outputted. This has to check if either of these are outputted, right? Because if either of these are outputted, that means there's going to be a shape on the line, which needs to be stacked. But if neither of these are outputted, then it can bypass it, right? And this one, so I just have 2 OR gates here. That's pretty simple. If this and this one has to check for all 3. If this or this or this is being outputted, then it goes to the stacker. Okay. And then I just have a wire line here. I have lots of wires. Yeah, and this is just to help. This just carries the signal. And then we end with the crystal machine. And I have like pretty much the same thing here. This is another belt filter, and this just checks. Well, first of all, it checks, is the crystal on, right? Remember, I have the 2 crystal lines. If either of those are on, that means it needs to make crystal. It needs to crystallize it. So it sends it to the machine, and if not, then it just bypasses it. And the way the machine works, the crystal machine is very similar. It has a very similar to the painter, and it just decodes the color, then sends it to the mixers, and then it just sends it to this crystallizer. I guess the important thing to note is that crystallizers need twice as much paint as painters, or twice as much paint as the shapes, I guess, as the inputted shape. So if for one input shape line, it needs two paint lines to keep it to 100% efficiency. So I just repeated the mixer here, and of course, which also means that I have 6 input colors instead of 3. So yeah, it's very similar to the painter. It's just a big decoder, and then yeah, then it outputs the shape to here. So then once the shape, so at this point, the layer is done, right? The layer is complete. The final step is to determine if you're going to stack the layer or if it's the complete shape, right? So here, this is just a trash system. It checks it. Well, it deconstructs the layer, and then it checks if it's the right shape. The reason I have this is because the train system, there's a lot of like latent shapes that or misprint shapes in the system, because it tends to back up. So and the problem is that misprint shapes will reset the train loading, right? So if there's a single misprint shape, it completely removes every shape, every other shape has been inputted. So instead of having that, I just have a filter, and it just checks. This just outputs the layer, like the current layer, and if it's not the current layer shape, then it gets thrown in the trash. And then the final thing you have to do is to, so as I said, the final thing is to determine, are you stacking the shape, or are you sending it to the vortex, right? And yeah, so this just takes this just asks if there is if there's a next layer, then we're we're sending the shape to be stacked. If there's not a next layer, then yeah, this is the stacker. Yeah, so like it's just an unstacker. If the right line is being outputted, that means that there's at least 2 layers to the shape, which means that this layer, the bottom layer, needs to be stacked, right? And then the green line just sends it to the vortex. So if we follow the red line here, it goes all the way to here, which is the next branch of the anything machine, right? And I guess it goes here, I guess. And this is just an additional stacker, right? So it sends the shape here, then it stacks the bottom shape on top, and then it has the same thing where it checks if it needs to be sent to the crystal machine. If not, then it just bypasses it. Yeah, it's not that complicated actually, because it's the reason it's not that complicated is because the way the random shapes are generated is that they never have like any funny business, as like you would see like in like these task shapes where like you have like empty layers below crystals and stuff. They never have any of that, because the way it works is it just takes a random asteroid shape, which is just any of these shapes. You know, it can be any color, any shape, and then it could pin push it, and then it could send it to a crystallizer, and then it just repeats that process. It takes another asteroid shape, it could pin push it, then it stacks it on top, and then it could crystallize it. And it repeats 4 times. Yeah. So that means there's never any funny business. So you can have like a pretty basic system to create the shape. I suppose I can explain now how to get single pins. So if I head over to my pin factory, the way it works is that you start with any 4-cornered shape. We're just going to pin push it. Then we're going to cut into 2 halves. So we have 2 halves that are pin pushed. Then we send it through a crystallizer, doesn't matter what color. Basically, what this creates is that we have the bottom layer. We have a top layer that's half shape, half crystal, and the bottom layer is completely crystal. Then we pin push the crystal layer, and I just rotate it, and then I have it. So now we have, since the crystal breaks every time whenever you cut it, we're just gonna have the side with the shape on it. So that just leaves just 2 pins here, and then we can just stack the 2 pins together, and now we have a that ends with a full 4-pin shape. Yeah, I think that's pretty much everything. Just a big train line with many trains. Yeah, basically I'm just going to each shape and cutting it up into 4 corners, and then giving those 4 corners to separate trains that can be picked up. Yeah, and just repeat that for each full shape. That's why it's so long, because I could have done it where I just create full shapes, but I was kind of lazy, and I just did it where I just look for full shapes on the maps, which made the train lines longer than they should be, but it works, so I think it's fine. Yeah, and the colors work the same way, where they just pick up. They go to stops where they just pick up one crate of each color, and then they have all 3 colors on them, and then they drop it off to each painting station, and then the crystal machine just picks up 2 crates of each color, so it has to go through 6 stops. So I think that sums up every moving part of the Make Anything machine. If you like this game, I definitely suggest that you make one, because it's a very entertaining process to figure out all the logic. But I will say, definitely test your machines like rigorously, because test your blueprints, because there's about 15 times where I found out there was like a small issue with the blueprint, and I had to copy and paste that about 20 times, which is very repetitive and very annoying. It's a lot easier to just test your machines first, and then not have to worry about copy and pasting them again and again. It also saves you a lot of blueprints. But yeah, that's about it. Thanks for watching. Goodbye.